I'm introducing our project on behalf of Group 2 on the impact of accessibility on HDB. We will analyze how accessibility to urban amenities like MRT stations, bus stops, hawker centers, parks, schools, and healthcare facilities influences HDB rental prices across Singapore. The whole workflow is implemented using Python and geospatial analysis tools. The whole process can be divided into 4 phases, corresponding to our 4 code scripts, which can be seen here. The first 2 are for data preprocessing, including geocoding and format processing. The other 2 are spatial autocorrelation and accessibility analysis. The first part was geocoding 173,000 HDB addresses, so we developed this custom pipeline using the OneMap API, but due to the time limit and the magnitude of dataset, this could take several hours, so we're not going to demonstrate it here. The function downloads rental data from data.gov.sg, and then normalizes street name abbreviations like AVE to avenue, and geocodes each address to get precise coordinates. The final geocoding achieved a 98 geocoding success rate, converting text addresses into geographic points so we can analyze it later. And for the next phase, we use this pipeline to load and convert all the data we acquire, either in zip format or GeoJSON format, and convert them into uniform shapefile and project them onto SV121. And to identify spatial patterns, we perform spatial correlation analysis using Moranzai. Our results, which can be seen here, shows a Moranzai value of 0.257 with a p-value less than 0.001. Meaning rental prices exhibit strong spatial clustering. In other words, expensive units tend to be near other expensive units and affordable ones clustered together. The LISA analysis further identifies specific hotspots like the central business district and cold spots in peripheral estates. For our final phase, we used this pipeline. First, we defined 2 functions. The first one is calculate nearest distance. This function uses a KD tree spatial index to efficiently compute the distance from each HDB unit to the nearest amenity. For 173,000 units, this runs in just 2 to 3 seconds. And for the next function, count within, this accounts amenities within walking distance buffers, for example, a 500-meter buffer, and count how many bus stops are within this buffer. And here are our results. Here is the distribution of 6 accessibility indexes, which is highly skewed in most type. And here are the 6 panel maps showing the accessibility spatial pattern across Singapore. And the key finding of our study is that accessibility strongly correlates with rental prices. After controlling for flat type and the rental proof date, which are the 2 biggest influences for rental prices, we have computed the coefficients of 6 types of accessibility, and this plot shows this relationship holds consistently across 6 types of accessibility indexes, which are all significant. The most important finding lies within the spatial parameters of regression models. The spillover parameter RAU equals to 0.3, which means 30% of the rental change in the neighborhood are transformed into the rental change in a certain location. At the end, we also check the model fit and the residues, which can be seen from the R-square here and the Moranzai spatial indexes. And we can see that the spatial regression models perform slightly better than the OLS. So to summarize, these projects demonstrate that accessibility is a major driver of HDB rental prices in Singapore, particularly the accessibility to hawker centers, parks, and MRT stations. Thank you.